So a key part of yesterday was knowing that you could add a base to cancel out a log. All right, that was a huge part of yesterday's homework. Okay, you could legally introduce a base on both sides. And once you introduce the base on both sides, that would cancel out the log. So you can do the opposite. So can somebody tell me what the converse of that statement would be, the opposite of that statement? You can legally introduce what? If you could introduce a base on both sides to cancel out a log, what do you think you could also introduce? Yes, sir. All right, so today we're going to see that you can also legally introduce, you just have to be the right log, a log on both sides to cancel out a base. It's the same as any other math you've done. If you want to cancel out a square, you introduced a square root on both sides. If you want to cancel out a square root, you introduce a square on both sides. As long as you do it on both sides, it's legal to do. So let me show you how that works out. All right, so we'll start with solve 5 parentheses, 3 to the x equals 45. Now the same thing is true. We cannot have a coefficient, just like we couldn't last time have a coefficient. So that 5 is sitting there as a coefficient. 5 is a coefficient, 3 is the base. That's the difference. Okay, 5 is outside the parentheses. That makes it a coefficient. 3 is inside the parentheses. That makes it a base. So you can't have a coefficient, so you need to get rid of it. What's the easiest legal way to get rid of that 5? Sure. So we'll divide both sides by 5. That will give me 3 to the x equals 9. Now some of you know your math facts already, and you know what x is going to be. All right, can you do that as a mental math? Sure, x has got to be 2. Well, what if you had a total brain, just it washed right out and you didn't remember that math fact? Well, then you can use a log on both sides to cancel out the base. This is how that works. Okay, the log you introduce has to have a base of 3 because it matches the base that's in the parentheses. And on the other side, you have the log, and then you have the number 9. Hopefully, you recognize 9 as a math fact, and you change the 9 to a 3 squared. And then you pull both of the powers to the front. So that'll leave you x in front of log base 3 of 3, and it'll leave you with 2 in front of log base 3 of 3. And one of our properties is that when the log base matches the other number, they cancel out completely. So the log base 3 of 3 cancels out that 3, and the log base 3 of 3 cancels out that 3, and you still get x is 2. Now, you could have saved yourself those steps if you remembered your math facts, but I'm just saying, hypothetically speaking, suppose those math facts you just totally forgot what they were. It still works. You can put a base on both sides. Excuse me, a log on both sides to cancel out the base. Now sometimes what you get right here is not going to be a math fact, and so you have to do the log on both sides. So let me show you some other ones. Okay, here's another one. So let's solve 3 as the coefficient, 10 as the base, x plus 2 is the power, 27 is the number. So first you got to get rid of the coefficient. So know the difference between 3 and 10. 3 is the coefficient, 10 is the base. So we'll divide both sides by 3, which works out nicely. We get 10 still as our base to the x plus 2. and we get 9 again. This time there's no math fact here. 10 and 9 are not related in any way with a math fact, so we have to use a log. What is the right log to use on both sides? Say it again, Devin. A common log, right. Okay. All right, so we're going to take the common log to the base of 10 on that side, and the common log to the 9. But we still want to recognize 9 as a math fact number. So we want to say, all right, I've got the log of 10 to the x plus 2, and I have the log of 3 squared. All math facts should be written as their powers. Then you pull both the powers to the front. The 2 goes to the front, and the x plus 2 goes to the front. So x plus 2 together in the front, log base 10 in the back, 2, and the log base of 3. Only one of the logs is going to cancel out. It's the one whose log base matches the number that's in parentheses. So we understand that there's a tiny little 10 right here. Okay, that's a common log. It's on both sides. There's a tiny little 10 on both of them. So it only cancels out the one that has the 10 with it. So it's just this one that's going to cancel out. So that leaves me with x plus 2 by itself equal to 2 log 3. I don't have to worry about the 2 log 3. I don't have to worry that it doesn't cancel out, because my job is only to get x by itself. And so the last step to get x by itself is a simple subtraction. So we'd have 2 log base 3, and then subtract 2 on the end. And that's the end of that answer. Okay, let's try another one. Yes? No, the base is not 3. What's in parentheses is not the base. Did I say base 3? Is that what I said? 2 log base 10 of 3 minus 2. If I said it, I misspoke. I'm sorry. We have it recorded. We could probably check what I said. But I may have said it wrong. So thank you for listening closely on that. All right, let's try another one. 20 times 1/2 to the x over 3 equals 5. All right, well, first I got rid of the 20. That's the first thing I got to do. So I'll divide both sides by 20. That will leave me just with 1/2 to the x over 3, and it will leave me with 4. 1/4, sorry. 1 over 4. Now, 1 over 4 and 1 over 2 are both math fact problems, both math fact numbers. So far we've seen 9 as a math fact, okay, but you got to see 1 over 4 as a math fact as well. Okay, so just to remind you that 1 over 4 is a math fact because 4 is a perfect square and it's a fraction. So that's related to 2 squared, but it's not exactly 2 squared, it's 2 to the negative 2. That's what 1/4 is as a math fact. Yeah. Say that again. We can, but we want it to be as small as possible. Okay, so the base is 2 is smaller than 4, so you really want it to be as small as possible. All right, well, if I can make 1/4 into 2 to the negative 2, what could I do on the other side with the 1/2? 2 to the negative 1. And still with x over 3. All right, so once I've got my math facts done, then I use the right log on both sides. And the correct log to choose is log with a base of what? 2. Exactly. I want the log of the base of 2. So the log of the base of 2 will help me cancel out the 2. And I do it on the other side as well. Log of the base of 2 when I use a log, any power, all powers, move to the front. So I've got lots of powers here. All of them move out to the front. So does that one. So that will give me a -1 and an x over 3 all in front of log base 2 of 2. And on the other side it will give me -2 in front of log base 2 of 2. So here I have an opportunity to cancel out the log base 2 of 2 on both sides, which leaves me with -1x over 3 equals -2. Maybe you want to cross multiply here, like drop a 1 under there or something. So when you cross multiply, you get -1x equals, bless you, -6. So x is 6. But it's not going to work so slick if you didn't have your math facts. If you didn't know your math facts about the 2, okay, right here at that point, then it's not going to work out nicely for you. You've got to recognize those math facts at the beginning. Okay, here's another one. Okay, let's try a 35 e to the 0.025x equals 140. Just because it's e doesn't change how we do the problem. We still need to get rid of the coefficient and then to use the right log on both sides. So what's the coefficient in this case? 35 is the coefficient. All right, with e, we understand that there are implied parentheses around the e. So the 35 is the coefficient, so we want to divide. That gives me e in the understood parentheses to the 0.025x. And 140 divided by 35 actually works out nicely to the number 4. 4 is math fact. So recognize that as 2 squared. Now I need to choose the right log to use on both sides. What would be the right choice here? Okay, which one do I choose? The one that's going to cancel out on the left side? Or do I choose one that'll cancel out on the right side? Well, where's the x? Okay, so you got to focus on the left side. I need to cancel out what's on the left side. So what would cancel out in e? ln. ln is the right choice. That's the right logarithm here. So I'm going to use ln around the parentheses of e to the 0.025x. And I'm going to use ln around the parentheses 2 squared. And both powers get pulled to the front. So I get 0.025x pulled out in front of the natural log of e, and I get 2 pulled out in front of the natural log of 2. The natural log and the e cancel out because, remember, I'll write it in there, there's an understood teeny tiny little e right there. We don't write it, but we understand that it's there. And so those cancel out. The other side doesn't, because the base e doesn't match the 2, and so you just leave it. So we're left with 0.025x equal to 2 ln 2. And so then we just have to divide. And so x would be 2 ln 2 over 0.025. And you leave it as a fraction unless the book tells you that you're allowed to use a calculator. It's not grayed out, and then you're allowed to actually finish and type it in. But if you're not allowed to use your calculator, then you just got to stop and leave it in its fraction form. So just watch the directions so you know when you can and can't. Okay, let's try another one. So I've got solving 5 minus 4 e to the negative x equals 3. Okay, so what to do when? Trevor, can you get me started on that one?
Yeah.
Yeah, I'm trying to work on getting that x by itself, so I need to do some legal math to both sides to to work on getting rid of something.
Five, right?
Yep, 5 would be the first thing. We're going to take that 5 away on both sides. Okay, and so then negative 4 e to the negative x, and we're left with negative 2. Okay, Veronica, take it the next step. What would I do to both sides next? Okay, divide by negative 4. All right, that gives me plain e to the negative x equals 1/2, which is a math fact again. Okay, 1/2 is a math fact. What's it the math fact for? All right, good. You guys are getting the hang of it now. All right, once we have that, okay, Angie, give me the next legal move. Both sides. And remember, our goal is to try and get x by itself. So we got to think of something to get rid of on the side where x is. Yeah, good. Okay, we want to add the ln. The next thing we want to get rid of is the e. So we'll add an ln around the side where the x is, which means we have to do it on the other side also. And then we pull the powers to the front. So negative x is in front of ln e, and negative 1 is in front of ln 2. The ln on the e side cancel out. I'm left with just negative x equals negative 1 over ln 2. My last step would be to get rid of the negative 1 by dividing. So divide both sides by negative 1. So x by itself is just plain old ln 2. That was all that was left. Okay, I only have 2 more examples, which should leave you with at least 20-25 minutes to work on your lesson. Okay, here's the second to last one I've got for you. 2.13 raised to the x equals 5.4. Clearly, we have to get rid of the 2.13. The problem is there's no nice log to cancel out the 2.13. There just isn't. But that doesn't stop you from using legally a natural log on both sides. Okay, what I don't want you to do, what would be illegal, would be you to try and divide 2.13. Okay, that would be, whoops, especially not 21.3. Okay, that would totally be the wrong move at that point. Why? Because this isn't a multiplication problem. You can only divide when the problem is a multiplication problem. This is a multiplication. This is an exponent problem. And so doing that would be the complete wrong move. That would not be legal. What would be legal is for you to use an ln. So we're going to use an ln on the side of 2.13 and an ln on the side of 5.4. Now neither of those numbers are math fact numbers. So that's fine. We can keep going without using a math fact. What's the next thing to move in this case once I've done that? Yeah, I can move the x to the front. And so the x is now in front of ln of 2.13. And now you can do the division that you wanted to do at the beginning, because this is now actually a multiplication problem. Now that it's actually a multiplication problem, I can divide by the ln of 2.13. And so x alone is the ln of 5.4 and the ln of 2.13, which you will leave as a fraction unless you have access to a calculator, at which point you will type in that into your calculator. Again, you would not cancel out the word ln, because that's a word. We can't cancel out words. You can cancel out numbers, but ln is a word, and so you cannot cancel out the natural log word. You just leave it, the natural log of 5.4 divided by the natural log of 2.13, and if you have a calculator accessible, if you're not grayed out, then go ahead and type that full thing into your calculator and get the value. Okay, last one. Yeah?
So would that also equal the log base 5.4?
It would, It could be written as, yeah, this is the base change formula, the log of 2.13, I think is what you're going for, not the log base of 5.4. But it's much preferable to write it in its natural log form. Okay, much preferable. Okay, last one. This one's going to look scary, but it's really not. Okay, it's really not. It's like you see a scary house or a scary room or something, and then you turn the light on, and it's really not as bad as what you originally thought it was. Because originally you maybe saw shadows and things that freaked you out a little bit, and this is not as bad as you think. All right. Should we all read that? Oh. Getting a package delivered or something at home. All right, we are going to take the fraction 250 over 1 plus 20 e to the 0.4x equals 100. So like I said, that looks really intimidating at the beginning, but we're just going to flip that light switch, and hopefully the shadows will go away and we'll be able to see it more clearly. So the first thing I'm going to do is drop something under the 100. Okay? When I do that, that should at least be clear to you what the first step is going to be, right? What are we going to do now? We're going to cross multiply. All right, so 250 to 1, that's easy. We get 250 equals. Now going the other direction, we've got 1 to the 100 and the 20 e to the 0.4 to the 100. So 1 times 100, okay, that's 100, plus the 20 e to the 0.4 to the 100, you're going to multiply the coefficients. 20 times 100. That's 2 times 1 with a couple extra zeros. Count up the zeros, so it'll be 2,000. Okay, it's 2 times 1, and then there's 3 zeros, so it'll be 2,000 e to the 0.4x. So hopefully when you put the 1 under, that at least is clear to what the next step is. All right, it should be clear. Okay, Aviana, maybe what the next step is? Subtract 100. Okay, 150 equals 2,000 e to the 0.4x. Okay, Katie, how about the next step? Something about the 2,000. I'm trying to get x by itself, so yeah, let's get rid of the, how do I get rid of the 2,000? I can divide. Okay, I can divide because 2,000 is multiplied by e to the 0.4x, so I can use division. Without a calculator, the best I can do is reduce a set of zeros, leaving me with 15 over 200. I could probably reduce that again with 5, but, all right, and that got rid of the 2,000. I really just wanted to get rid of the 2,000 on the other side. Okay, Hayden, next. Next legal move. Okay, tell me what you want to get rid of. Okay, and how can I get rid of the e? Okay, so I'm going to use a natural log on both sides. I'll put parentheses around the 15 over 200, and I'll put the natural log around the e to the 0.4x, which allows me to move the exponent to the front. So we get ln of 15 over 200 with a 0.4x in the front of ln e. And ln e is to the point now where it cancels itself out. So the only other thing I have to do to get my x by itself is get rid of one last number, which is what? Right, and I can use division. So I'll say it's the ln of 15 over 200 divided by 0.4, and I will leave it as a fraction unless I have access to a calculator to turn it into a decimal. Okay, so 22 minutes left in class for